Physics Challenge 2, Special Relativity. Now, geostationary satellite. That means it's rotating at the same speed as Earth's rotation. It's complete one rotation within 24 hours. So, after 3 years of circling, the time has to be adjusted, the clock has to be adjusted. Why? Because this one going faster than the station on Earth, the speed is faster, so there is a time dilation. So in order to know how much time dilated in 3 years, we need to find out this V. Okay, V equals R omega, right? And we know omega is 2 pi over 24 hours, right? 60 times 60, that's the omega. So the R omega square is acceleration for the satellite equal to G M over R square. Okay, so RQ is going to be Gm over omega 2, omega square, right? So that's the height of the satellite, and this distance is R, so the speed is R omega 2 minus R, this guy, omega 2. So time difference is given by omega square R minus R. Not the time difference, speed difference, delta V. Okay, so let's plug in the number, right? So we have gravity constant and the mass of the Earth, so we can calculate all of this. Let's do that. Let's find out R first. We need a calculator. We hit the calculator, right? So 6.674 times 6 is a mass. Okay. That's the 4 times 10 to the 14 per omega square. Okay, so omega is 2 times 3.14 divided by 24 divided by 60 divided by 60. 7.26 times 10 to the minus 5. Okay. So 4 divided by 7.26. So let's make it 21.7, right? So this way R can be whatever 10 to the 7. So that's gonna be the R. Actually, okay, here's a mistake. After using calculator, this is not correct. It's so 3,000 kilometer. Got it. So that's R. So distance will be this minus this, 42,000 kilometer. 42,000 minus 6,378. Okay. Now, so the speed difference is actually, we multiply this together, and also v is not the square here. Okay, so let's calculate. 35,622,000 times 7.26 equals 1, 2, 3, 4, 5, 2, 5, 7, 8. So delta V is 2,586 meter per second. Well, 2.5 kilometer per second sounds a lot, but it's not much, because time dilation factor is 1 over v square c square 1. So when you calculate this, the regular calculators cannot do it. Let's use the Excel sheet, because the difference is too big, the number is too small. So let me do this. 3 years, 3.57 millisecond. Okay, so it's quite small. This is gonna be 1.00, like 10 of them and something, and you have to multiply this dilation factor is per second, so 3 years. So the time delay caused by relativity effect is 3.57 millisecond for 3 years. That's very small. Beside that, there is another factors for the clock. General theory of relativity is going to introduce later. You will learn that the time dilation due to the gravity. So if you look at gravity situation, this gravity is higher than this. So there is some time dilation on this observer on the Earth. So that has to be compensated, some delta. So the satellite time dilation effect is even smaller after taking consideration for that general theory of relativity. So it's pretty minute time delay caused by satellite. But if satellite is flying faster, like higher orbit, it has much more effect. And the time, the clock occasionally has to be adjusted. That's what this question is about. Okay, so I hope you enjoyed this video, and please check out the video too. If you like, subscribe.